Figure 6.10, Simulating the Dice Game Craps. In this program, we're going to write a simulation of the casino game called Craps, in which the user rolls 2 dice. And on the first roll of those 2 dice, if the user or the player rolls a 7 or an 11, they win. If they roll a 2, a 3, or a 12, they lose. And any other value is that player's point, and the player must roll that value before rolling a 7 in order to win the game. If they roll a 7 on a second or subsequent roll, they lose the game. And I've already executed this program 4 times to show you some of the common cases. So here we have a case where the player rolled a 7 on the first roll, so the player won. In this next one, we have a case where the player rolled a 4 on the first roll, so the point is 4 because they didn't roll 7, 11, 2, 3, or 12. And then we went through a series of subsequent rolls, none of which were 7s, and eventually we rolled a 4 again, so we won the game. This next case is a loss on the first roll because the player rolled a 2. And the last case here, we show you the player rolling an 8, which is their point, rolling several subsequent times, and then rolling a 7 before rolling an 8, and therefore losing the game. So basically, we've implemented this game in Figure 6.10, and we're taking advantage of a couple of features that we haven't looked at before. If you're coming from the C programming language, you may already be familiar with the rand and srand functions. They're in the C standard library header called stdlib.h. In C++, all of the C standard library headers have been renamed to remove the .h and to start with the letter C. So for example, down at line 11 here, this is the old C programming language time.h header file renamed for C++ to be ctime. And the difference between the C++ versions of these headers and the C versions is that all of the functions that are defined and declared in these headers are part of the standard C++ namespace. So in order to use them properly in our code, we have to have a using declaration that specifies either the explicit functions we intend to use with std::, and the function name, or we have to have a using namespace std statement like we discussed back in the earlier lessons. So we're going to use rand to generate random numbers, srand to seed the random number generator, and time will be used to help us also with seeding the random number generator. Basically, we want to make sure that the pseudo random numbers produced by rand change sequence every time we execute the program, and the best way to do that is by passing to srand a value that's constantly changing every time you run the program. And of course, the time of day is constantly changing. We also have a roll dice function in this example, and the example is nice just because it shows you a lot of the different control statements that we've been looking at so far. It also gives us a chance to have our own separate function being called directly by main. In prior programs, we've certainly called functions from main, but they've been member functions of an object of a class, such as gradebook, not separate, standalone, globally accessible functions, and that's what roll dice is in this example. Now, in the main function is where we implement the logic of the craps game simulation. The first thing we've got here in main is a new data type called status, which is an enum data type. Enum stands for enumeration, and it's used to create named constants in C++. The syntax is the enum keyword followed by the type name, a set of curly braces that delimit a list of named constants, and a semicolon to terminate the new type. By definition in C++, the first constant in the list gets the value 0 by default, and each subsequent constant gets 1 plus the previous constant in the list. So 1 will be 1, lost will be 2, etc. You can also explicitly assign values to the named constants by providing an equal sign and a value. So if I do that, then the value of 1 is 1 plus the value of continue. So now you can see 1 is 2, and lost is 3. So you can explicitly assign values. The values don't need to be unique, by the way. You could explicitly assign a value to every constant in the enumeration. However, the names of those constants must be unique for use in your program. And once you create this new data type, you can then declare variables of the type, and the values of those variables can only be the values that are listed in the enumeration. Now, for the purpose of the game, we've declared an integer called myPoint, where if the user does not win or lose on the first roll, we'll store their point so that we know what we need to roll to win the game in the future. We've also declared a variable of type status called gameStatus, which we'll use to store continue, won, or lost based on the status of the game at any time. Now, when you're going to do simulations using random number generation, once in your program you'll want to execute the srand statement like the one on line 25. And srand receives as its argument an unsigned integer value, and time gives us the time of day. And basically what we're doing is using the time of day to seed the random number generator. And we did this because time is constantly changing, and therefore every time we run the program we get a different time of day, and therefore a different value for the srand argument and a different sequence of random numbers. The argument 0 in the to the time function is simply saying that we don't intend to store the time in a variable in memory. This is actually a pointer argument. Some of you who might be coming from other languages like C will be familiar with the concept of pointers. Basically, a pointer is just the location of a variable in memory, and we can, if we want, provide the location of a variable in memory here, and time, the function time, will place the value into that variable. In this case, we don't intend to use that concept. We're just going to use its return value, and the way that you say that you don't want to store a value, the time value, in memory is to simply pass 0 as an argument. Next, at line 27, we call our roll dice function. And again, this is not a class-driven example, so we're going to have just a standalone roll dice function, global function. I'm going to jump to its definition so you can see what we've done here. And basically, roll dice is not part of a class. It's just a standalone function that takes no arguments and returns an integer. The function is going to produce two random numbers in the range 1 to 6. And the way that we're producing that range here is we're calling the rand function, which, depending on your platform, is typically going to give a number from 0 to the maximum upper value for a signed integer. So on some systems, if it's a 2-byte system, that'll be just over 32,767. If it's a 4-byte system, that will be up to and a little bit over 2 billion. Excuse me. If it's an 8-byte system, it'll be a much larger value potentially. But the key is that the range of values it produces is far larger than what we're looking for in this example. We only want numbers in the range 1 to 6. So by using the remainder operator, we scale down that range to a total of 6 values, 0 through 5. And then we add 1 to that result to get a number from 1 to 6 as our randomly chosen value. So we calculate the two, or we acquire, I should say, the two die values. We sum the two dice, and then at lines 80 and 81 we display what the player rolled, and at line 82 we return that sum, which we need in our program to figure out whether the player has won, lost, or needs to continue rolling. And for that purpose we use a switch statement. Based on the sum of the dice, we're going to compare the value of sum of dice to the cases for 7 and 11. If the sum of dice is either of these values, then we're going to set game status to 1, and we're going to terminate the switch statement. If the if the sum of the dice is 2, 3, or 12, we're going to set the game status to lost, and then we're going to terminate the switch statement. And finally, for all other values, we didn't win and we didn't lose, so we're going to set the game status to continue to indicate that we need to continue rolling the dice. At line 43, we store the sum of the dice in myPoint so we know what we need to roll to win the game later. and then we display that value as well. And remember, the break statement at the end of the switch is unnecessary because we're already going to reach the closing curly brace of the switch in the default case here. These other break statements at lines 35 and 40 are extremely important. However, if we don't include the break statement and the case is 7 or 11, we'll execute line 34 and then continue and execute line 39, which would not be proper logic for this program. So the break statements are extremely important for terminating a particular set of cases and allowing the program to move on with the next statement in sequence after the switch. Now, based on whether or not the game status is equal to continue, when we reach the next control statement, our while loop, if it's equal to continue, that means we need to keep rolling. So we'll roll the dice again. We'll check to see if the sum that we just rolled is equal to the point, in which case we've won the game. Otherwise, we'll check to see if the sum of the dice is equal to 7, in which case we've lost the game. Now, if none of this if-else statement gets executed, that would mean that we still need to continue rolling, at which point we'll come back up and do it again. And then finally, when we do get out of that loop, we will print out whether or not the player won or lost the game. The thing that's nice about this example is that it gives us a chance to show several different control statements. Also, the concept of a global function, roll dice, that can be used throughout our program. We used it in 2 different locations. And then separately, we used random number generation for the first time and introduced how to create named constants with an enum data type.